Hello and welcome to this episode of Microchips, and on the bench today we have this Cobra 148GTL-DDS that we're going to be putting a DDS modification onto. But before we start, don't forget to like, share, subscribe, comment, join the Facebook group, join Patreon, buy me a coffee, have a look at my website microchips.net where all my boards are, and let's get started. So here we have the Cobra 148GTL-DDS, a bit of a Swiss cheese model with plenty of holes on it. This was kindly donated to me for this project after putting a call out on my group, so very big thanks to the donator of this piece of equipment. And initial looks inside, just as he said, everything should be functional inside. It's just really ropey on the outside. But that was perfect for our needs. So let's have a look on the underside, see if we've got any horrors under there. And yes, we have a diode modification on the back of the binary adders. Looks like round the back of the output transistors has had a bit of a hard life, but shouldn't be a problem. A nice tidy board for the extra couple of bands that it's got. But apart from that, it looks okay, should do the job. So I think there's a couple of cut tracks down there that we're going to have to deal with, but shouldn't be a problem putting it back to standard, because before we do this modification we're going to have to put this radio back to some form of original operation. As you can see, they got extra clicks on the band select. So yeah, in the day that would have been absolutely fine. So let's whip the shield off, see if there's any surprises underneath there. And there seems to be a red trimmer on the back of the board. Now initially I thought this was for a VCO, but no, this is for the 10240, which actually is quite handy for this modification, because if the 10240 is off, then the whole DDS is going to be off. So yeah, it's practically on the back of where the 10240 lives, so yeah, that's fine. We can use that. But yeah, quite a nifty little trimmer for the 10240. So we'll start to disassemble it. We won't be needing this, so that's fine. But everything else on the back looks tidy enough. So what we're going to have to do is lock this to MX2 as we normally do. That will give us mid-band codes. As you can see, somebody's been having fun and games with putting holes in it, and that front metal work's not going to come off without being quite destructive. I think somebody might have super glued it on. But I've got another one that I've filled holes in and sanded down, so that just needs finishing off, and then we can get a decal fitted to it. So let's have a look at the radio as it is. So yeah, it's working just fine. There's a 10kc switch on it, so we'll have to reinstate that, which is the jumper that's normally cut. So yeah, we can do that. So we need to decipher what's going on with this band switch. One of them is going to be the SFT wire. Of course we can just ground that, and there's a couple of wires going off to the diode board, and the rest of them are going to the MX1, 2 and 3. So if we carefully take these wires off, it says carefully, but try not to burn his fingers. They start to come out. So we need to lock MX2. MX2 should be the purple wire, which it is. So we'll find where the purple wire is, and we can tack it onto the mode switch next to it, which provides 8 volts. And the rest of the wires can come out then. So that's where we're going to be tacking our MX2 wire. Because that's basically just an 8 volt supply. So just like so, and that will lock the binary adders to midband. Found this is the easiest way of doing this. So quick test as we're going along, make sure everything's still working, and yes, confirmed we were on midband. So now we can remove the rest of the wires from the band switch. We won't be needing MX1 or MX3 anymore. So what we'll do is we'll desolder those and pull them out from the board. Make it nice and tidy. So these two wires, brown and green, there we are, drift off to the diode board. So yeah, quite a simple modification, but quite effective for an extra -40 and +40. Not a problem at all. So we'll desolder them. We'll take out the band switch, and let's get this diode board out. So there's a few extra wires, so that'll be for the 10kc. We won't be needing that, so that can come out. Just like so. So yeah, 10kc wires. We can just get them off the back of the switch. Just like so. No one just fell off. But yeah, it's fine. So, the diode board. So let's carefully pick away at this. Lift the wire links. Sorry about it not being in focus. Yep. As soon as we start to lift the wire links, the board starts to move. We'll take that one off from the top of the board. Let's get that out of the way. Okay, everything looks okay under there, to be expected. And we'll whip this wire off as well. Just like so. So JP54 needs to be reinstated. That being something to do with the 10 kc. If we don't reinstate that, we might have problems. And this looks like a cut track here, but that's not a problem. We can link over and correct that. I'm just checking with the frequency counter that everything is working correctly. So 965, 975. So because we're fitting a DDS unit, we're going to have to take the channel change out. Just like so. Now, the way that these adders work is that the channel change actually grounds the signal. So if you measure the voltage with nothing connected, they're all going to show us high. But we need to ground some of the connections. So the one at the top is the actual ground. So what I'm doing is I'm just making sure all the holes are free. This is in preparation to lock the radio to channel 1 midband, because the way the DDS is going to work is that it does not require the original channel change at all, but we're still using the PLL and the filtering, so we can actually keep FM, because one of the big problems with some of the other DDS units is the way they do it, they lose FM. But the way that Chris and myself have designed this is that it keeps FM. So I'm just desoldering the TX and RX LED, which we will be using. And that's our channel change out. So we've got the SFT wire and we've got our TX and RX LED wire. It's actually marked on the board TX and RX for the LED, just in case we ever get them mixed up. And the SFT wire is marked up as well. So we need to put this radio to channel 1 midband. So I've modified a pin header like so. Basically we just need to ground 2 pins. And this is being a bit fiddly, even though it shouldn't be. But basically the pin closest to us is ground, and then we're going to ground those 2 with this pin header. So doing this should lock us to channel 1 midband. And a quick test. There we go, channel 1 midband. Absolutely fine. Now you can see the KC shift is still operational, but we're going to have to take this out anyway, due to the way that the DDS works, is because it's a digital system. There is no varicap diodes for the KC shift, so we'll have to rewire all that. So now the fiddly bit, we take the front off. Now we've got to mount a board, which is our new display board and our rotary encoder board. So using these standoffs, just like so, we have our rotary encoder board and OLED board. Now on the OLED screen I've had to lengthen the pins. You'll notice that the holes are elongated just for alignment, plus it's got provisions on this board for the reversed VCC and ground, so these must be connected correctly, because different OLEDs, the VCC and ground are swapped. So on the board we just make sure that we've linked the correct pins to the P1 and P2. There's a close-up of them. You can see ground and VCC is reversed with these two different types of OLED. But we're going to be using this white one. Also as well, I've had to file the holes a bit for the standoffs because they weren't quite lined up correctly. Just a couple of mils, but you know. Now this bit is the most fiddly bit ever. Trying to get this aligned and trying to get the OLED screen aligned. And it took me quite a while to work out the best way of doing this because I wasn't happy with it because it just wasn't centered. And you see there's plenty of room for adjustment. Now there is another way of doing this. You could cut that top piece of metal work across the top. That would allow a little bit more movement. But I'm trying not to cut as bits away. So just having a look at the initial alignment, and it's a bit low for my liking. So I've got to think of a way of hiring it up a bit. So putting my finger through the old channel change hole, we can actually hold the OLED into place. And we can test fit it. TCXO DDS. So this will be the board we use. I'll get back to fitting a channel change in a minute. So using the SI5351. And we're going to be fitting a nice 25 MHz TCXO to this. Which is obviously the key part to this. So we're just doing a little bit of soldering. So I'm actually using a cheap hot plate underneath this just to warm the board up, and then we'll put the hot plate at solder melting temperature to melt the parts into place. But as good practice, we're just going to tin up the parts we need. So I've given them a quick wipe down with some ISO. And let's fit our voltage regulators. So nice beefy 7805 voltage regulators. These things will drive into a short circuit and carry on. There's no problem. Not like some of the other ones that just self-destruct and throw 8 volts everywhere, or 12 volts. But you can see we've got the regulators on the heater plate. We've got it up to temperature. You can see the solder's melted. But just as a final touch, we need to add a tiny little bit of flux. That was too much. So we'll come back and try it with a tiniest little bit of flux. And you can see with the addition of flux, the soldering just turns beautiful. Just like so. It's not very healthy to breathe this stuff in either. So always have some form of extraction. So yeah, those are nicely in place. Let's move along to fitting the TCXO. So again, exactly the same thing. We've tinned the pads up. We've got our TCXO. I'm just going to drop it on top of the pads. You can see they're already at temperature. And then we're just going to add a little blob of flux next to it. And there, that makes it solder just nicely. A little bit of a nudge with the tweezers, and you can see the surface tension of the solder is pulling it into the correct place. So we'll take it off the heat plate and let it cool down. And there's our finished unit. So we've got some resistors there for the AM, FM, USB, LSB signals. We've got our TCXO underneath the can. We fitted some output capacitors. And the input capacitors and a power connector. So just needs a quick scrub with a toothbrush. Now you probably saw this on the previous video. On the original SI5351 units with a crystal produced this. You had a couple of peaks there that were being generated by the board. And using our TCXO with no can on it, you can see the 25 megahertz signal along with the 2330. And we put the can on top and it's gone. So using the can in conjunction with the TCXO has produced quite a clean signal. So we're just running the calibration script for this board, and you can see we're 0.2 of a hertz up. Now back to the display fitting. So I worked out if we just cut these corners, we can move the board up a tiny little bit more. Because I didn't really want to cut the metalwork on the radio, but we can do this instead. And also I've removed the black holders off the pins, which is going to give us even more clearance. Now the most important part about this is we put insulation between the pins and the radio case. Or you could just cut this piece of metal away and there's no problem. But if you didn't want to cut the piece of metal away, insulation is an absolute must because it does touch. But doing it this way, it's a tight squeeze, it's a pain in the backside. But once it's in, it's aligned and it looks good. So there's our TCXO DDS unit fitted to the side of the radio, just temporarily with one screw. Now I was using this shielded cable to start off with, but I didn't like the way it was lying in the radio, so I got rid of it in the end. Just went for bare cables, as you can see. So we've got power connected up, we've got the screen connected up, we've got the encoder connected up. We can go for a quick power up. So we'll switch it on comes the screen. Now the flickering is obviously the camera. It doesn't do that in real life, it's just the refresh on the camera. But yeah, encoder's working fine, correct direction, push button's working, beautiful. And you can see we've even got holes there for the TX and RX LED. So for this DDS to work, we need to take out the 15 megahertz crystal, and we need to take out this transistor, and this is where we're going to be feeding the signal. If we don't take out the 15 megahertz crystal, it's going to cause problems. So that circuit must be killed. And you can see we've put it in and it's operating correctly. So that's just using the push button. VCO needs adjusting, but yeah, it's fine. Beautiful. So initial test there, we're operational, and we've got the radio working on the DDS, and that's where it connects to. Going to the clock 0 signal and soldering the braid to the can nearby. Now to decipher the band switch, the mode switch, because we do need control signals from the mode switch to tell the board what mode it's in. So that's our colours. Now on one side of the switch the FM and AM is tied together, but we can actually use the other side of the switch and we can get all our FM, AM, USB and LSB signals from there, because obviously we need offsets, because we need USB and LSB offsets. And also as well, we've got it on the screen as well. That does actually show that it's working and it's responding to the correct signal. Now I'm going to look at the TX and RX LEDs. We can use the TX LED to get our TX signal, because it's just 8 volts. So that's the RX and TX on the display working. Now we're moving on to the clarifier. So this model has actually got a tune on. It doesn't have to be used. The tune on wire can be grounded for the clarifier and the tune to be on all the time, but I wanted it switched. So there's our clarifier and KC shift out. We will be using the same pot, and we don't need to de-notch it either, because there is a dead zone in the centre. So here's my initial wiring of this. Little did I know I had it back to front. So we've got the 5 volt fine, 5 volt coarse, which goes to one end of the clarifier, ground goes to the other end of the pot, and the signal comes out the centre. And yes, I got them back to front. So we just reverse the ends. And that should work nicely. So as you can see, the clarifier doesn't work. And that's the tone switch, you idiot. There we go. So there's our KC shift. Fantastic. So that works nicely. Now on this board as well, we've got a provision for a plus and minus 5 kC switch, so we're going to fit that as well. So we're going to use the SWR, and pins 6 and 7 on the board will be the plus and minus 5 kC, with the centre pin going to ground. So as you can see, a quick way to go below and above the 5. So plenty of tune options for this. So the TX and RX LED has a resistor from the centre leg down to ground, obviously for current limiting, so we need to address that. So we'll get the same value of resistor. I think it's a 680 ohm. Now putting the TX and RX LED in, you can see it just about comes through. The legs are just about long enough. So we'll solder those into place, just like so. And we're going to add a resistor from the centre pin down to ground, which is an easy point there. And there's our TX and RX working as it should do. So for the reference there, that's the orientation of the wires that's needed. But you'll have to make sure that you put the LED in correctly, of course. So always check it with a meter. Now next on the list is a little bit of extra. Yeah, I know some people will like it, some people won't like it, but this radio is going to be tricked out with some bits and pieces. So we're going to fit this EC2 Echo board. So using the same M3 brackets, mounted it to the side. So we've got mic in, mic out. Those will be easy enough to find, because one's on the back of the microphone socket, one goes to the mic gain variable at the front. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1. Okay, that works nicely. Mic 1, Alpha Tango mic. Mic 1, Alpha Tango mic, location United Kingdom, QSL. Yeah, QSL, my friend, QSL 5 and 9, 5 and 9 into Manchester, United Kingdom, and the name is right there, my friend. Okay, 7-3 to you, good DX, my friend. Have a good afternoon and evening. Okay, thank you very much. Contact. Good luck, good DX, 73, my friend. A nice quick contact there, shows it's working. So the next thing, we're going to upgrade the regulator. Now somebody's already put another one in, and I'm sure this tip 126 is a Darlington pair, which isn't really correct, but hey ho, it works. Whilst we're at it, we're going to put a shiny new signal meter in, because the one that was in there's all yellowed, and plus we've not got the SWR graphics in it as well. So we're going to fit that, and that should make our signal meter look like new. So obviously we've taken away all the SWR switch as well. So the main wire there is the brown wire that comes off the back of the SWR switch. Now again, don't do what I did and put the wires back to front, because when you switch it on, the needle goes backwards. Which I did here, unfortunately. But again, it's a quick quick fix. If you turn it on and the needle goes backwards, you know something's wrong. So we're soldering the wires for the bulb. Sorry about the focus. So one side goes to that point on the board and the other side goes to the negative on the S meter, which I suppose it could go to any negative. It doesn't have to be that exact one. But that's where it's come from, so that's where it's going back. And yes, it does get hot, because soldering irons do get hot. And once I'd switched it on and found out the needle had gone backwards, we take it all off and we put it back how it should be. There, that's how it should be. I think it does look a bit better with a nice new signal meter in it. Let's switch it on and have a look. And yeah, fine. You may notice the display has changed a bit as well, because I've been altering the code. Now you notice on UK it says please change to FM. Switch it over to FM and it says UK 40. So the next thing, we're going to fit a variable power. Now this variable power only works on AM and FM, but we're doing it the same way as a Gentech that I had in. So basically we're using the SWR wires, and we're going to bring the wires neatly from the front of the board. So we connected that up as such, and also we need a resistor on the back, and these wires go down to the front for the calibrate and SWR, so it makes it nice and neat, and there's no wires running from the back to the front. And as you can see, we have a nice healthy output. So variable power works nicely. But again, only on AM and FM. And because we're doing that, we're going to do what we said before and replace that Darlington with a nice big tip 36C, I think it is.
Well, I've done both ends of mine, so...
So there's our transistor with our bent legs, correctly bent. And there it is in place. And there's it soldered in place. Nice big beefy transistor there. Still going to get hot, but the next thing we're going to do is we're going to do a quick modification to the front end. So this transistor needs to come out. It needs to go into that one's place. And the transistor we replace at the front will be a 2SC2999, which should give us a little bit more gain at the front end. So this transistor comes out and we can disregard this one. We don't need this one anymore. And the first transistor can go in its place. When it decides it wants to come out. So that one comes out and that one goes into the place where we've just removed. That one goes in there, just like such. And the 2999 goes into here. That should give us a little bit more gain on the front end. So we'll just solder that into place. Just like so. That's our front end done. So now we're just going to go for an alignment. And now it's everybody's favourite part. Yeah, that's what I think of that. But you know, for all you Cyanad fanboys out there, let's have a look how the receiver's doing. Yeah, beautiful. Has to be expected. That is absolutely normal. I've not balanced the front end out yet. And there it is in the real world. So you can still hear the tone. Nice and sensitive. Now we'll just go down onto channel 1 low band and have a look at that. Yep, as you can see, channel 1 low band is not as sensitive as the higher up, so I'll have to balance that out, which is fine. And whilst we've got a signal generator on it, we'll have a look at the FM discriminator. So using our scope, just get this to a nice sine wave, and that should be nice. And one of the last parts of the DDS modification is replacing the 10695 crystal with the DDS board, which now controls that signal.
3 days later.
So we finally got our decal from our friends at Print Extreme, and he has kindly given the microchips community a discount code for his website printcut.uk. Using the code microchips10 you get 10% off the products on his website, so go check them out. So yes, we've got the decals now. I've ordered two different types of decals, a black and a silver one. I wanted to see which one would be nicest, and I've chosen the black one. I'm not going to show you yet and spoil it. Unfortunately, this front I had was a bit of a Swiss cheese. It's got some holes in it. I've filled it, but it's not good. So we put the decal on, and we fitted some double-sided tissue tape on the back to hold it in place, just like so. And where the channel display was, we've fitted a small perspex window, and we've blacked out the area around the OLED screen, so it should just be black. You shouldn't see any of the silver screen there. And here it is, the microchips Cobra 148GTL-DDS, with a lovely echo unit in there, variable power, coarse and fine works, and of course the OLED with the DDS on it. So it's all turned out very nice. We've had the case powder coated as well. Unfortunately the front chrome work isn't perfect, but you know, it'll have to do. And it was a donation from one of my kind group members. So here's the DDS switching on, comes straight on 555, and we use the push button and we can cycle through the bands. Big thanks to Chris DT307 for devising this wonderful VFO system. So as you can see, it's just constant, it doesn't wrap round, goes from low, mid, high, straight through to UK 40, and if you're not on FM, it says please change to FM. So go back to USB, and you can see it's seamless and works beautifully and smooth. So TX and RX works on the display, and the red LED of course, all modes on the display. Ignore the flickering, that's just the camera interfering with the display. You know, the refresh rates on the display. So let's try and get a good angle to show the clarifier, which is an absolute pain to do when you've got a camera in front of it. So with tune off, and we put tune on, I've left the notch in the centre, there is a dead zone in the centre, so fine goes 2 kcs and coarse goes 5 kcs aside, plus we've got 5 kc switch up and down, just in case you needed another switch to move kcs, but it's a nice addition to drop to zeros. So yeah, it's absolutely beautiful, it works a treat. You can see, it says there, change to FM, switch it over to FM, it comes up with UK 40 on the display, frequency at the bottom but channelized display at the in the middle. We've also got 10 meters on there as well, which we can cycle through. So low, mid, so 385 being the USA channel for LSB. Obviously there's 555 on the plus 40 or the high band. Yes, good afternoon, this is Mike 1 Alpha Tango Mike QSL.
I will change my direction to you, Mike, because in South America, move down, go ahead, Mexico 1.
Yeah, good afternoon, this is Mike 1 Alpha Tango Mike. The name is Graham, Golf Romeo Alpha Hotel Alpha Mike. Unfortunately not in South America, but United Kingdom QSL.
QSL, my friend, I'm so sorry to waiting, my friend, but I'm copying you 519, and that moment before, with I'm beaming to North South America, 515, now perfect, my friend. Mexico 1, America Tango, Mexico 9K2JJ. Your audio clear and loud. My name is Abdullah Graham, QSL.
Yeah, QSL there, Abdullah, no problem at all. Very good afternoon to you. Yeah, 5 and 9 plus 10, absolutely booming across into United Kingdom this afternoon. And when you were beaming to South America, I was still receiving you on a very, very strong 5 and 9. I will let you carry on with your DX to South America. I hope you get some very nice contacts there, Abdullah, and I wish you a very good 73 and a very good afternoon.
QSL, my friend. Thank you, Graham, for the signal report and the short QSO. Mexico 1, America Tango, Mexico 9K2JJ. 73, stay healthy, my friend.
73, Abdullah, 73.
Thank you, Mr. 73.
So there, an absolutely fantastic contact from Kuwait, Abdullah in Kuwait. Very happy with that. A few minutes later, he was gone. Propagation must have just dropped off. Must have just got it at the right time. But yeah, very happy with the performance of this radio, and very happy with the VFO and the conversion in general. So I know it's been a long one, but I hope you enjoyed the video. Don't forget to like, share, subscribe, comment, join Facebook, join Patreon, buy me a coffee, have a look at my website microchips.net. Don't forget Print Extreme. Thanks for watching, and we'll see you in the next video.